Hello, welcome to Jet Mathematics. I remain your host, Milton Ebiwari John. Today, we are looking at a problem on the board. It says, determine the nature of roots of y equals to 3x squared minus 2x minus 3, and hence determine the minimum or maximum value of y and its corresponding value of s. Quickly, we are going to solve this problem. Y is equal to 3x squared minus 2x minus 3. Now, to know the nature of root, what kind of root will this equation give to us? Will the roots be real and distinct? Will the roots be imaginary or complex? Or will the roots be equal and distinct? How do we know this? Remember the discriminant we discussed in our previous videos, that the discriminant d is equals to b squared minus 4ac. Alright, this will help us determine if this the roots of this the nature of roots of this quadratic function. So quickly, our b is minus 2, so put that in, minus 2 squared. The coefficient of x is our b. Then minus 4, a is 3. A is 3, which is the coefficient of s squared. And then c, our c is minus 3. Minus 3, which is the constant term. Minus 3. So solving this, we'll have d equals to 4 or plus, this is 12 times 3, 36. So finally, we say that d is equals to 40, which implies that d is greater than 0. And we said if d is greater than 0, then the roots of that quadratic function will be real and distinct. So therefore, this quadratic function will have real and distinct roots. Alright, because the value of the discriminant is 40, which is greater than 0. Alright, then we can go further to determine whether we can determine the maximum value of y or the minimum value of y. Obviously, we know that a is greater than 0. A is 3. A is equals to 3, and that implies that this function has a minimum value. It has a minimum value. Okay, because we said if a is greater than 0, then the function will have minimum value. So what's the minimum value of y? Y minimum is equals to, remember the formula I gave in our last video. It says 4ac minus b squared over 4a. So all we need to do is to substitute the value of a, b, and c. So y minimum becomes 4. Our value of a is 3, the coefficient of s squared, and then our value of c is minus 3, our constant term, and our value of b is minus 2, which is minus 2 squared, over 4 times 3. Solving this, we have minus 36, then minus 4, all over, this is 3 times 4, 12. So this gives us this gives us y minimum equals to minus 40 over 12. Reducing this to its lowest term, y minimum becomes minus 4 here is 10 and 4 here is 3. So the minimum value of y is minus 10 over 3. Also remember, I told you, if your value is negative after solving, if your value is negative, then know your y is minimum. If your value is positive, then know that your y is maximum. Otherwise, I said you can use the value of a to know if it's going to be minimum or maximum. If a is greater than 0, it's going to be minimum, and if a is less than 0, it's going to be maximum. All this we discussed in our previous videos. Now finally, let's find the corresponding value of s for which y is minimum. The corresponding value of s for which y is minimum. And I said that happens at the line of symmetry. Y is minimum at the point of line of symmetry on the curve. And so we say that therefore the corresponding value of s is at the equation of symmetry, which is s equals to minus b over 2a. S equals to minus b over 2a. So plugging this, we have the corresponding value to be s equals to minus b is minus 2. We have minus 2 all over 2. Then our a is 3. So at the end of the day, this gives us 2 over 6. And s is equals to 1 over 3. Alright, so this is the equation of line of symmetry. S equals to 1 over 3. And it's also the corresponding value of s for which y is minimum. Please share, like, and comment on this video. Bye.